Hello everybody and welcome back to the Epic Flight Academy. This is the private pilot ground school course. My name is Mike Thompson. Now remember, to be successful, you can't just watch these videos. In addition to these videos, you must be studying the Epic's online course. And thirdly, review this content with your flight instructor. So lately, we've been talking about the power plant. We see the 5 major parts to aircraft systems: fuselage, wing, power plant, empennage, and landing gear. Last time we talked about the power plant, the cowling, and the 4-stroke operating cycle. Now, let's get into the air induction systems in a little more detail. The induction system on our aircraft pulls outside air into the engine. Take a look at the nose of this aircraft. Up here you can see air coming into the cowling. That's cooling air. Look down here, you see this rectangular shape? That's the filtered air intake. Now on your panel, you have controls for these systems. And I want to point out 2 in particular. First of all, this black knob is the throttle. We're going to talk about that more later. You're going to hold that in your hand. Your flight instructor will work with you on this. Forward, more power or full power. As you pull it aft, less power all the way to idle. The second one is this red knob. Pilots refer to this as the mixture knob. What is it mixing? It's mixing fuel and air. And we'll talk about that in just a second. Again, your flight instructor will work with you on this control. Pushing the mixture forward is what we call a full, rich mixture. Pulling the mixture aft is what we call a lean mixture. The air that comes in through this air filter is routed to the carburetor. Here's a cross section of a carburetor. This is an updraft carburetor because on the bottom here you see these blue arrows moving up towards this big throttle plate right here. These blue arrows are depicting that air that came in through that filter. And this big throttle plate is controlled by, guess what? Yeah, that black throttle that you were holding in your hand that we saw just a moment ago. The fuel-air mixture happens right here at the discharge nozzle. This discharge nozzle in the middle of this airstream is discharging fuel from this float chamber. The amount of fuel that is allowed into that discharge nozzle is controlled by this needle valve. Look at this long, thin needle valve. That needle valve is controlled by, you guessed it, that red mixture knob. That's why we pointed out the throttle in the mixture. The throttle is controlling this big throttle valve, and the mixture is controlling this needle valve. When that fuel and air are mixed in this Venturi, they are sent to each cylinder in my engine. And last time, remember we talked about the 4-stroke cycle. In the intake cycle, that's what it's intaking, that fuel-air mix from this carburetor. Now, this carburetor is very reliable and works flawlessly over a wide range of conditions. But there is something that you need to learn about, and your flight instructor will introduce this to you, and you'll learn more about controlling it if you're operating a carbureted engine. And that is Carburetor Ice. carburetor ice forms in this Venturi, and as that ice accumulates, it eventually chokes off the flow of that fuel-air mixture. If we let enough ice accumulate, that could eventually lead to an engine failure, because you have literally just choked off its fuel-air supply. Now, why does this ice form? This ice forms because this air is moving through this Venturi. Now, if you think back to aerodynamics, you remember that that Venturi causes an increase in velocity and at the same time a drop in pressure. Remember when we talked about that drop in pressure, we said that there is an accompanying drop in temperature. When that temperature drops, any moisture that's in the air will condense out of the air and freeze on these parts inside the carburetor. That's carburetor ice. What makes this hazardous is that we could be on the ground in a nice 70-degree shirt sleeve kind of a day, and ice would be the furthest thing from our mind. What we may fail to remember is we take this aircraft up in altitude. The air is cooler because we've gone up in altitude. Well, what if the air is still, maybe I go up 6,000, 7,000, 8,000 feet and the air is still 50? It's still a long ways from freezing. Remember that Venturi? When that air moves through this Venturi, that temperature drop could be as much as 30 degrees Fahrenheit. So between the altitude and the pressure drop in that Venturi, we could easily drop the temperatures into the freezing range. And we could see this ice build up in the Venturi. Potentially hazardous. If we let it continue, it'll literally choke off our engine. So what do? Lo and behold, your flight instructor will introduce you to something called carburetor heat. Now, if you take a look at this diagram, you see the red mixture knob on your right, the black throttle knob in the middle, and a small square black one to the left. That is carburetor heat. What carburetor heat does is allows warm air to flow up through this Venturi and melt that ice. If you can picture your air induction system from the side, it would look something like this. In normal operation, that air valve is open and the inlet air will come in and up toward that carburetor and off to your cylinders. If you suspect carburetor ice, wait a minute, how will I know if I have carburetor ice? If your engine is starting to lose power, if it's starting to choke off, you're going to notice some power reduction. You're going to think immediately, aha, that could be ice. I'm going to pull that carburetor heat knob to the on position. When you do that, it'll be in the position you see here. Notice the intake air is going overboard, and air that was warmed by the muffler is now being directed into the carburetor, right up through this Venturi, melting that ice. Well, if you're following along and you're thinking to yourself, well, that melted ice, that means that there's water and melted ice going into my cylinders. Isn't that going to disrupt my engine operation? That's good thinking, and the answer is yes. Fortunately, it'll be very, very brief. That warm air will come through that carburetor, that ice will melt, it'll go right through that cylinder, and your engine will have a little cough, be right back to normal. So that is kind of an overview of how your induction and carbureted systems work. To get an idea of where this is located on the aircraft, take a look at this schematic. This is a gravity-fed system from a high-wing airplane, metal wing tanks, fuel tanks up in the wing, and the fuel flows down to the selector and eventually down and forward to the engine to the carburetor. Your carburetor is actually located on your engine. Well, folks, next time we're going to talk about fuel injection systems. And that's it for today. See you next time.